Let's take a look at another example of cycling in equations using multiple of k. Remember our last example, k was 8, and the goal was 27 to the 99th power. Right? And so what did we do? We took the base of the exponent and divided it by 8. So 8 into 27. So there's our k, there's our base. 8 into that 3 times, remainder of 3. So once we found the remainder from the base divided by k, we looked at the powers and then divided and took 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. We found that the remainder was 3, 1, 3, 1, which is a cycle length of 2. We then noticed that the exponent 99 is an odd exponent, which means it's going to be congruent with all of these. So therefore, 3 to the first is 3, which means that 27 to the 99th is actually congruent with 3, and therefore we could have a solution like 2 plus 1 is congruent to 27 raised to the 99th. And of course, if 3 is congruent, then so are all the modulos of that. 3, 11, 19, and so we're going up by k. Starting at 3, going up, we could go down by, so that would be -5, and subtract 8 from that, -13, and so on and so forth. All right, so anything that equals -13, anything that equals -5, anything that equals 11, anything that equals 19 is congruent with 27 to the 99th power. Let's do another example with a different cycle length. Let's say k is 10. And we set the goal equal to 32 raised to the 67th power. 32 raised to the 67th power. And we want something that's going to be congruent to that. So what do? We divide k into the base. Divide 32 by 10. 10 into 32 goes 3 times, 30, and there's a remainder of 2. So we take that remainder and we raise it to its powers, to the first, to the second, to the third, to the fourth. We get 2, 4, 8, 16. We divide k into that and find the remainders. 10, this is a remainder of 2. 10 into 4 gives us a remainder of 4. 10 into 8 gives us a remainder of 8. 10 into 16 goes once, gives us a remainder of 6. And we've seen this before. We know that this is going to be 2, 4, 8, 6, again and again. We actually did that. 2 to the 5th was 32. So that's 2. Once we see that a number repeated, we know that this is the cycle length, 4. Great. So we know that the cycle length is 4, and therefore we know that 32 to the 67th is going to be congruent with one of these powers, okay, of 2. But which one? What we have to do is divide now the 67, because that's how many times we're going to multiply 32 by itself, and we're going to divide that by 4. So 4 into 67, 1 times 4, 27, 6 times 4 is 24, and we get a 3. So what's going to happen is we're going to go through raising these powers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That's what we just did by getting this remainder of 3 here. We didn't have to really go through the 27 times, but we find that the 27th iteration of doing that is 2 to the third. Therefore, 32 raised to the 67th is congruent to 2 to the third, or 8, which now means that, let's erase that. So 32 to the 67th is congruent with 8, That means that if we go up by 10, 18, 28, 38, ad infinitum, or down by 10, -2, -12, and so on and so forth, all those things are going to be congruent with this. And so let's say 8 is congruent. 4 times 2 is congruent with 32 to the 67th. Circle the goal in solution, submit it, you got it. That's it. That's cycling in equations. You should be able to apply that to many other situations and goals.